For problem 2, we'll use implicit differentiation to determine dy dx for the equation x squared minus y squared equals 1. So we've provided a graph for you. So an implicit function is a function that has x's and y's mixed together inside the function, and they generally can't be separated. So every time we see a y, we apply the chain rule to that particular expression. So the warm-up in part A asks us to find f prime of x, assuming that f of x is differentiable. So that means every time we see f of x, we get to assume that f prime of x exists. So we're going to do this the way we would any other derivative. So the derivative of x squared is still just going to be 2x. But now what we have here is a chain rule. We have some expression squared, so that's the outside function, stuff squared. So the derivative will be 2 times that stuff raised to the 1. And then the derivative of the inside is just going to be f prime of x. Now, on that same line of thinking, we're going to then take the derivative of the expression that we were given. So I'm just going to rewrite the equation. So you take the derivative across with respect to x, which means everywhere you see an x or a constant, you do the derivative as business as usual. But when you see a y, we have to apply the chain rule. So the derivative of x squared is 2x. The derivative of y squared is 2y, that's the outside function, times dy dx. Then the derivative of 1 with respect to x is just 0. So we're not done with the problem until we solve for dy dx. So now it's just algebra from here on out. So I'm going to leave everything without a dy dx over here on the left. I'm going to move all the terms that have dy dx over to the other side of the equation. And I can see that I have a 2 on both sides, and my 2 cancels. Now, to get dy dx by itself, I just divide both sides by y. So this is my final answer, and it's perfectly natural to have some y's in our derivative, because if the original function has x and y mixed together and they can't be separated, it's totally plausible that the derivatives may contain some x's and y's mixed together that may or may not be able to be separated. So it is possible to have an implicit problem where there aren't any y's in the derivative, but it's quite common for it to happen.